Good morning. This lesson is from our Integrated 1 class. This is a review for Unit 2, Quiz 1. But before I get started, I want to say I hope everyone is doing okay out there. Let me go ahead and go over a couple things really quick. I left the 6 steps up on the board from Unit 1. I did add a little comment to Step 6 that you switch the inequality symbol if we divide by a negative. And I added Step 7, and that's the graph. Let me talk about this chart over here. This chart is the inequality symbols, and we use these to describe positions. If I have this symbol, which is less than or equal to, or this symbol, which is less than, we call that left of. That's how we're going to describe positions. These mean left of, greater than or equal to, or greater than. This means right of. If I have less than or equal to, or I have greater than or equal to, that means I have a closed circle. This is the border of the shading, which we'll talk about in a second, but this counts as a solution, which we'll see here in a minute. If I have less than or greater than or left of or right of, we need to draw an open circle. Now remember, I tried to teach this as us describing position. And x, which is a variable, or any variable, m, v, y, w, doesn't matter. That means that's the shading, and where we shade, that is the solution. And we graph our problems on a number line. All right, so let's just go ahead and jump right into this. And again, hopefully this helps make sense of this section. And hopefully by us seeing this again, it makes it easier for us and we do much better on the retake. All right, so let's just go ahead and jump right into it. Problems 1 and problem 2, I'm asking you to graph. I should have erased that. I had to remake this video because my camera ran out of storage and I forgot to erase that. But anyways, I would like to graph this, so we're going to graph it on a number line. And let's just, let me get a pen that works. Here we go. All right, let's try that again. That one did not do very good. And that looks more like a smirk than a line, but anyways, let me translate this. The shading is on the right of 2. I'm going to put a 2, I'm going to put a circle that's closed, because that's what my table says to do, and I'm going to shade to the right. The shading is on the right of 2. That's how I graph that. Now, problem 2, it says negative 2 is on the left of the shading. I don't like talking about the number before the shading, so I want to change how I describe the positions. If negative 2 is on the left of n, that means that n is on the right of negative 2. We're just describing where they're at. So let me draw my graph here. And I'm going to put a negative 2. This tells me that I have an open circle. And it tells me that I'm going to shade to the right. Now I did mention that closed circles are solutions. And so greater than or equal to, or right of or at. So 2 is right of or at 2, or 2 is greater than or equal to 2. That's why this is shaded in, it's a solution. And all these numbers will be right of 2. Here, negative 2 is not right of negative 2. It's, negative 2 is not right of negative 2. That's a false statement. That's why it's open, so it's not a solution. Moving on to problem number 3 and problem 4, I'd like to write 2 inequalities for each graph. Again, all I'm doing is describing position. All right? So here I see that I have shading is left of negative 3 and my circle's open. The shading is left of negative 3. I could also say that negative 3 is on the right side of the shading. That's how I would write 2 inequalities that describe this graph. That's all I'm asking for. Problem 4. The shading is on the right of 5. And the circle is shaded in, it's closed. So the shading is on the right of 5, or I could say that 5 is on the left of the shading. And make sure that I have the right symbol that shows that my circle is shaded in or closed. All right, let's move on to problems 5 and 6. Solve and graph. Problem 5, I need to eliminate a fraction, so I need to do step 1. Remember, it's either going to cancel or multiply. So I'm going to multiply everybody by 4. And here I get This side cancels, so I'm left with n is greater than or equal to, or the shading is right at 12. Close circle at 12, and I shade to the right. There we go. That's all I'm looking for on problem 5. Solve for it and then graph it. That's it. Problem 6. I can't eliminate fractions, I can't distribute, I can't combine like terms, I can't get all variables to one side, I can't add or subtract away a number. And it says equal signs, but it should say inequality. I didn't change that, I'm sorry. But can I divide away a number from a variable? And yes, I can. I can divide away a -2. So that means that -2, and I have to switch this because I divided by a negative, is on the right of v. Now, I don't like to graph if I start with a number. I like to reverse it. So if -2 is right of v, that means that v is left of -2. Now let me just real quickly explain why we switch that when we divide by a negative. And I have this little number line right here. When you change the signs of numbers, you change their location. You switch their positions. And when you switch their positions, you have to stop talking about being on the left. You have to stop talking about being on the left and start talking about being on the right. Or you have to stop talking about being on the right and start talking about being on the left. So right here, 5 is on the left of 6. But if I change their signs, I've now changed their positions, and now 5 is on the right, or -5 is on the right of -6. That is why when we divide by a negative, we have to switch to inequality. So hopefully this helps. I'll be posting Unit 2 test video here later today, and the Unit 3 stuff as well. That's going to do it for this video. Again, I hope everyone's doing all right out there. See you guys later. Bye-bye.